change of base formulas, one for log and one for ln. Why do we need to use this formula? Because when you use a calculator to evaluate common logarithm, so let's say log base a of 5, so take a look. Take out your calculator, press the log key to see what happens. So when you press log, your calculator, I am using a TI-84 plus CE graphing calculator. When you plus log, they will not give you any opportunity to input the base. What happens if the base is not specified? When the base is not specified, that is base 10. But I want to do a base 8, but the calculator doesn't allow you to do base 8, then what do? We will be using the change of base formula, which is log base a of x, that is equals to log of x divided by log of a. So when you take log of x divided by log of a, so now you don't need the base anymore. But where is the base? This is base a, then we mention the base a in here. And then for ln, then that would be lnx divided by lna. So for log base a of 5, that is equals to log of a divided by log of 5. Actually, you know what? It's log of 5 divided by log of a, because we put the base in the denominator. And then what is that equals to? I have a screenshot for you, but that for ln, that is equals to ln 5 divided by lna. So in this screenshot and this screenshot, when you do this on your calculator, I would like you to type log of 5 divided by log of a in one line. Do you see this? Log of 5 divided by log of a. Don't just do log of 5 and then round it up, and then log of a and then round it up, and then you use log of 5 divided by log of a and then you round again. When you keep rounding like this, you are accumulating round-off error. Once again, when you round decimals and then keep rounding like this, you are accumulating round-off error. So that's why when you do the change of base formula, do all the computation in one line. And how many decimal places should we use? Let's use 3. So this is approximately equals to 0.774. So add 1 to the 3, 774. All right, so the log and the ln gives us the same answer according to what I show you right here. And then the next one, log base 6. That one is a 6. That looks like a B to you, right? Okay. I'm going to change that to a 6. So this is a log base 6 20. So that is equals to log of 20 divided by log of 6. For ln, that is ln 20 divided by ln 6. And then in the next line, you can see that that is approximately equals to 1.672. 1.672. Moving on to the next one, we have log base 3.75 and then 2. So that is equals to log of 2 divided by log of 3.75. And then for ln, that is ln 2 divided by ln 3.75, and then that will be the next line, right? 0.524. So that is approximately equals to 0.524 according to the calculation in my screenshot. And then the last one, log base 0.75 of 3. All right, so this is a log 3 divided by log of 0.75, and then for ln, that would be ln 3 divided by ln 0.75. According to the last line, that one is a negative, approximately equals to negative 0.262. Now, how come every single result is positive, but this one is negative? The negative comes from log of 0.75. Because for log, when you take a look at the picture, for log and ln, when x is between 0 and 1, the curve is below the x-axis, so therefore the y value is negative. So that's why the log and the ln 0.75 gives me a negative. Okay, so I know that is almost the end of the exercise. I have one more extremely important things to say. Now, take a look at the first line again. So you have log of 5 divided by log of a, ln 5 divided by ln a. Everything is absolutely right. When you write like this, that gives people a misconception. They might be saying, all right, so since log of phi divided by log of a, since you can use either common logarithm, which is the log, and the natural logarithm, which is the ln, to answer this question, is that means log of phi is equals to ln phi? Also, is that means log of a is equals to ln a? The answer is no. Take a look at this screenshot. So we have log of phi and ln phi. They are not the same, right? So log of phi is 0.69 and then the ln is 1.60. Same thing for the lake a. Log of a and ln a. They are not the same. And then I have a graph right over there. The purpose of that graph is I want to strongly emphasize that log and ln, they are not equal. And when do they equal? They are only equal to each other at the x-intercept, which is when x is equals to 1, y is equals to 0. Log of 1 is equals to 0, ln 1 is equals to 0. Other than this point, the log and ln, they are totally different. All right, so they are totally different. Okay, so that is the end of this video. Once again, use the change of base formula. Why are we using this? Because when you evaluate log using a calculator, they do not let you specify the base. So in this situation, you will have to use the change of base formulas, right? So we have one for common logarithm, log, and then one for natural logarithm, ln. All right, so that is the end of this video. If you like the way I teach math, give me a thumbs up, give my channel a subscribe. Truly appreciate your help. As always, I will see you all in the next video. Signing out.